Let me give an example just to see how this technique works on something whose length we actually know. If we look at the circumference of a circle, we know that it is long 2 pi r, and we know that the circle, of course, is all curved. It's not flat anywhere. However, our method should work, right? Well, the circumference of the circle is going to be equal to twice as much as the top half of the circle. And the top half, the upper half of a circle, has a formula that we know, or you should know, right? Is given by y equals square root of r squared minus x squared. So all we need to do is now we have to apply the arc length formula in this particular case. So first of all, we're going to start by, remember, in the formula we have to compute the derivative of this function. So we compute the derivative, and again, check it out on your own that this turns out to be the derivative. Now we have to square it. Well, that's not difficult. In fact, it is quite nice because we're getting rid of the square root. Hopefully that's going to make our life a little bit easier. All right. Now we're going to use our arc length formula. So the circumference is going to be twice the length of the upper half of the circle. And so that's going to be equal to twice the integral from a to b of the square root of 1 plus y prime squared dx. Okay, we know what y prime squared is. What are a and b? Well, if we look at the circle, of course, the left point is going to be negative r0, the right point is going to be r0, which means that our integral is going to be twice the integral from negative r to r of the square root of 1 plus x squared over r squared minus x squared, which is the square of the derivative we found. From here on is just basic algebra and antiderivatives. What do is we do a common denominator. Once we do that, we realize that the minus x squared and the plus x squared cancel. That leaves us just with an r squared, which we can take out of the square root sign. And that leaves us with 2r times the integral from negative r to r of dx over r squared minus x squared. And at this point, this is a basic integral question. You may want to even just look it up in a table of integrals or in your notes. And you'll know that this is going to be given by the inverse sine of x over r. So all we have to do is evaluate this at r and negative r. Well, at plus r, we end up with the inverse sine of 1, which is, yes, pi over 2. And at negative r, we end up with the inverse sine of negative 1, which is negative pi over 2. So all of that becomes 2r times pi over 2 plus pi over 2, which together makes it for a pi. And yes, the circumference of the circle turns out, as expected, to be 2 pi r. So this is just a very simple example to check that the technique works and to show you how it works. Now let's see how we can apply this same technique in another couple of very important situations.